Our next speaker is Nrwl's rock star, Isaac Mann.
If anyone can teach you cool stuff, this guy can.
If your end-to-end situation has you feeling kind of lost,
Isaac can show you how to fix it with half the cost.
All right, thank you for that introduction. I have a special deal for you, limited time offer, end-to-end testing at half the cost. I sound like a used car salesman, but I'm actually a senior Angular engineer at Nrwl. I'm also an instructor for egghead.io, and my Twitter handle is MannIsaac here, and this is me being very shocked and amazed at the content that I'm about to share with you. So I'm going to talk about testing. And the goal of testing is to stop bugs from entering into your production system. Just like germs, you don't want germs to get into your body. And I'm actually intimately involved with this particular problem right now because my family for the last week has been fighting a stomach bug. And I have a picture of them here. This is my family. And so this was the perfect time for me to leave the country and get as far away from them as possible. But so when we're dealing with germs, the way to fight against germs is to do consistent, boring habits, like washing your hands and eating healthy. And this keeps you from getting sick. So the same thing goes with stopping bugs from entering into your production application. You want to do consistent, boring testing that just stops those bugs from getting into your application. So if we have this sink here. Have you ever wondered why sinks are always placed in bathrooms or in kitchens? The reason is they want the sink to be available and easy to access so that you'll make the right choice, the healthy choice when you need to wash your hands. And so this talk is about doing the same kind of thing with testing, making it easy and more accessible to do the testing that you need to do to stop the bugs from getting into your application. I hope it'll be easy enough that somebody who's lazy like me will actually do some testing. Okay? So there's 3 tools that I'm going to talk about that I'm going to use in this solution here, NX, Storybook, and Cypress. So NX is a tool that we make at Nrwl. It's an open source tool. All of these are open source. They're all free. And NX is a tool for managing a monorepo setup. You manage the TypeScript in a monorepo. And the feature of NX that I'm going to focus on today is that NX knows the dependency graph of your code base, so that if you make a change in one particular place in your code base, it knows which other parts of your code actually depend on that change, and you can run tests that are actually affected by your code change and not the tests that are completely unrelated. So you don't have to run all your tests for every change. You just run the tests for the affected pieces of code for that particular PR or that particular change. So it speeds up your tests. The second tool we're going to use is Storybook. Storybook is a tool for rendering your components in isolation. So instead of rendering your whole application, you take one component, you render it on the page, and you can do lots of interesting things with this. Storybook has a big ecosystem of plugins, doing things like putting documentation around your components and doing lots of other things. But the main idea is it shows your component in isolation in your web browser. Cypress is a testing tool, and the main thing that Cypress does is it lets you write tests the way that a user actually uses your application. So instead of mocking things out and doing other things, that you're actually writing tests like a user. You could read through a Cypress test, and you know the actual steps that a user would take to mimic that in manual testing. So here's the metaphor we're going to use in this talk. Pretend this birdhouse is your application. And we need to paint this birdhouse. So in this metaphor, the paint is they're your tests. And we want to cover this birdhouse all around with paint so that no bugs are going to get into the wood, I guess. So in this metaphor, end-to-end testing is like this paint roller here. So you take one swipe of that paint roller, and it covers a lot of your app with tests. But this paint roller, there's no way it can cover your whole birdhouse because there's going to be nooks and crannies in the birdhouse that a paint roller can't get to. Okay, so this isn't the one tool that's going to solve everything. Now, unit tests, you can be a lot more precise with, and you can get into specific areas. But unit test is kind of like, it's not really the birdhouse that you're testing. It's like you took a picture of the birdhouse, and then you put it inside of MS Paint, and then you've got a pencil, and you're clicking individual pixels, and each pixel is a unit test. So you have to choose between, am I going to use end-to-end tests, or am I going to use unit tests? So I have 4 criteria to help decide what testing method we're going to use. So the first criteria is speed. How fast do these tests run? How quick are they? Second criteria is precision. So when you write a test, can you target a specific place in your application to test just that code and not accidentally test this other piece of code over here? So the third criteria is coverage. When you write a test, our whole goal of writing tests is to cover our whole application. So when you write a test, how much of your application are you actually covering? And the fourth criteria is fidelity. This is my favorite one because this is, we want our tests to mimic what a user actually does when they use our application. It's kind of pointless if we're testing things and our tests don't actually mimic a real world use case. There's no point to even doing the test, even if it's the most elegant test ever. So let's look at unit tests. Unit tests have high speed. They're fast. You can execute them quickly. They have high precision because they're targeting one specific place in your code. But they have low coverage because they're just testing this small piece of your application. And they have low fidelity because they're inherently testing your code the way a computer would test your code, not the way a user would use your code. End-to-end tests are basically the exact opposite. They have low speed, they're slow, they have low precision because end-to-end tests, they run against your whole application. And if you have 2 different end-to-end tests, the odds are very good that they're running over the same code just to get down to the specific part of the application that you're trying to test. If you got 2 different forms, 3 steps into your application, both the end-to-end tests that cover those 2 different forms have to go through the login and the 2 steps beforehand just to get down there. And so you're retesting a lot of your application just to run those 2 different unit tests, the end-to-end tests. But end-to-end tests are great because they have high coverage. You write one end-to-end test that covers a lot of your application, and they have high fidelity because they're mimicking exactly what a user would do in your application. All right, so let's look at fidelity a little bit. This is an example of a unit test. When I'm talking about low fidelity, when a user interacts with your application, they never think about fixture.detect changes. That doesn't make any sense to them. They're not even thinking about that. They don't think about fake async, and they don't think about tick. Like that's not in their mind at all. Whereas with an end-to-end test, like with Cypress here, you can read this and a user will actually know what these things mean. They can visit a URL, they can find a button that says click me and then click on it, and then they can look for text that says the button was clicked, and they can look for an input that has the label of Twitter and then type in my Twitter handle. That's all stuff that a user does. It's testing the way a user actually interacts with the application, so I'm calling this high fidelity. Okay, so how can we improve unit tests? Well, one thing we can do, we can just write more unit tests. And when you write more unit tests, basically what you're doing is you're trading speed for higher coverage. So you've got a lot of unit tests. Now your speed is lower because you have a lot of them to run, but your coverage is higher. There are some companies that have a requirement like 100% unit test code coverage. And so that's what they've done. They've traded speed for coverage to make sure they've covered everything with unit tests. Then when you have a lot of tests, you can use the ngx-affected command to only run the tests that you really need to, and that improves your speed again. So that's pretty good. That's making unit tests a more viable solution to use. But what about the fidelity down here? You can't really fix the fidelity of a unit test. That's inherent to what they are. They're testing the way a computer tests. You can't change that about a unit test. Okay, let's look at end-to-end tests. Can we make the precision better with an end-to-end test? No, not really. An end-to-end test, if you're serving up your whole application and running through it like a user, you're going to be testing code that you're not caring about in that specific end-to-end test. So you're going to be accidentally retesting the login form every single time and things like that. So what we need, if we're going to make things a little bit better, we need another kind of test. So this entering component UI tests. So I have an application here that I forked off GitHub. It's got a login screen and 2 routes, a home and a customer's route. And this is inside of an NX monorepo. This is what the dependency graph looks like. We've got the application at the top, an auth library, and then the home route is inside of the feature home library, and the customer's route is inside of the feature customers library. And then down at the bottom on the left here, we've got a shared components library, which has some presentational components that are being reused elsewhere in the application. So for a component UI test, what we're going to do is we're going to test the components inside of that shared components library. OK, so I wrote a plugin for NX at Nrwl/storybook that will help you automatically generate these component UI tests. So all you need to do to run it, you run ng-add at Nrwl/storybook to install it from npm. And then you run this schematic, ng-generate Nrwl Angular storybook configuration, and then you tell it which library to target. In this case, it's shared components. And it gives you some prompts here. We're just going to say yes to all the prompts, and I'll talk you through what this actually did for you. So it sets up Storybook for these shared components, and it configures it for you and generates some stories automatically. Here's an example of what it generates for one of the components in that shared components library, the info box component. The only thing I added to this that was not automatically generated for me is that imports line. I added the mat card module and mat icon module because this particular component is using the material card and material icon components. Okay, so it makes this stories file here. And then it also gives you a builder. So you can run ng-run shared component storybook, and that will launch Storybook in a browser for you. So you can look at the component in isolation. This is the info box component, and it has, in the top right is the component itself. On the left side, there's navigation to choose which story you want to look at. And at the bottom, there's some input boxes that let you control the inputs for this particular component. And as you change these inputs, you can see at the top what your component is going to look like and interact with it just like a user would. So this is really exciting, and Storybook has lots of other plugins you can do. You can add documentation for your components and the tabs at the bottom and other things like that. But there's another thing that this schematic did for us. It also added a Cypress end-to-end application here that points. It's not pointing at an application at the top like a standard end-to-end application would do. This one is pointing at the shared components library. And so what that will do is that Cypress application, you can write Cypress tests against the Storybook instance. So here's one of the Cypress tests that we can write here. So it's visiting a URL here. In this case, it's visiting the Storybook URL. And in these query parameters here, it's got knob icon equals person and knob message equals John. That's setting those input values that were in those inputs in the Storybook rendering there. And then afterwards, we're just testing that the component behaves the way we expect it to behave. So this is so you also have a builder for Cypress here. This will automatically start Storybook for you and then run Cypress against it. And here's what that looks like. When you run Cypress, so it's navigating to the Storybook instance. So this on the right-hand side is what Cypress sees, and that's just the top right portion of what Storybook rendered, which is just the iframe, which is just your component. And then it runs through a whole series of tests. And it's testing it the way a user would actually interact with that component. So this is what I mean when I talk about component UI tests. So component UI tests in this chart here, their speed is somewhere in between unit tests and end-to-end tests. So I put it at medium. Precision is high because you're targeting just one component. You don't have to navigate through your whole application to get here. But the coverage is low because it's just the one low-level component. But the fidelity is high because we're doing Cypress tests and we don't have to do detect changes. We don't have to do other things that a computer would do, but a user never thinks about. So we can do the same trick that we did with unit tests. We trade speed for coverage to change where those are. And then we can also run ngx-affected to speed up, to only run the component UI tests that we need to based on the changes. So if we're not changing anything in the shared components library, we'll never need to run these component UI tests because they're just depending on that shared components library. Okay, this is looking pretty nice. But I notice, let's look at these end-to-end tests again. We used ngx-affected on both the unit tests and the component UI tests to speed them up. Can't we do the same thing with end-to-end tests here? Why can't we speed up end-to-end tests? Well, the answer is that the way end-to-end tests are defined, you really can't use ngx-affected to speed them up at all. Because, and we'll get to why in just a little bit. But if you actually relax your definition of what end-to-end means, then you can. So if we change end-to-end tests to route UI tests, then we can actually run ngx-affected, and we can get that speed boost. So let me show you what I mean by that. So here's a standard setup here where you have your end-to-end tests at the top here, and they depend on the application itself. So these the red outline shows the code that's been affected. So in this case, I've changed something in the feature home library, and it shows that the affected libraries is that feature home library and the app and the end-to-end test. So if we make a change anywhere inside of this application, then all the end-to-end tests have to run. And typically when you write end-to-end tests, some of your end-to-end tests will be concerned with the home route, and some of your end-to-end tests will be concerned with the customer's route, and some will be global concerns as well. But if we make a change to the home route, what we'd really like is to have something like this, where if you make a change to the home route, we don't want to have to run the end-to-end tests that are only concerned with the customer's route, because that's a waste of time. Those will never fail anyway, because we want to make sure that that's because we want that to be separated. So we can do this with the same schematic that we used for the component UI tests. And so let's walk through how we do that. So the same command, same schematic, instead of saying shared components, we're going to say the feature home library, which is the feature library for the home route, and has the route level home component in it. And what that does is, so we can do the same thing. We'll have to put in some more in the imports for that story file. You have to include all the imports that the app module provides, and do some mocking of the routing a little bit. But it'll give you something like this. And so this is the home route rendered without the navigation on the side. It's just the home route. And it's all rendered in isolation. There's no inputs at the bottom, because this is a route level component. You don't have inputs in a route level component. But that gives us the ability to run end-to-end tests directly against that route. And this is what the Cypress test of that looks like. So why would we do that? Why would we want to do that? Well, in our original setup, our end-to-end test took about 106 seconds. And that 106 seconds you have to do every single time any change is made anywhere in the application. Okay? Now, when we change it to use route UI tests, and say we make a change just to the top-level app, that will take only 31 seconds. Because you're just testing like the routing configuration and some other global concerns. What if we made a change to the home route? Then you have to run the home route UI test and also the global app end-to-end test. That took 58 seconds. So this is pretty great. We're already getting some speed increases just by splitting those things up. Same thing for the customer route. That one took 66 seconds. You're running the customer route UI test and the app end-to-end test here. So what if you make a change that affects everything in your whole application? So sometimes you'll change something at the very bottom. It affects both the customer's route and the home route. And so then you'll be running all the end-to-end tests that you ran in the original one. It's just separated across some different applications. You'd expect that you'd have some overhead there, so it's probably going to be a little bit slower than the original one. But it's actually only 67 seconds. How could that be if I'm running all the same end-to-end tests that I was before? Well, yeah, the answer is I cheated. Not only did I run ngx-affected for end-to-end, but I added the -- parallel flag. And so I have the app end-to-end tests, the home route UI tests, and the customer route UI tests, and they're all running in parallel. So the running them all takes only as long as the longest one. In this case, the longest one is customer route UI test. So this is what I mean when I talk about end-to-end tests in half the time. So we've got 4 different types of tests here. What should I actually do? What should I actually take away from this talk? And what should I focus on? I'm a big fan of route UI tests. They're great for doing happy path testing. You go through and you can cover a lot with a little bit of effort, which I like that. I'm a lazy developer. Then use component UI tests to cover edge cases. You want to test all the different ways, all the different permutations of inputs on your presentational components. And you can handle things that your route UI tests wouldn't actually be able to cover. Then you still are going to need to do some global level end-to-end tests. You need to test things like global configuration, test things about like making sure that when you combine all your feature libraries together, they work together correctly. Test your routing, that it's configured correctly. But you have to be careful with these because you know that anytime anything changes anywhere in your application, all of these end-to-end tests will have to be run. And then you still need unit tests. Even though I don't like that they have low fidelity, there's going to be parts of your application that you simply can't test with these other methods. So you need to have unit tests for things like internal APIs in your application that they don't really have a UI associated with them, or other things like that. So this is what I would recommend. So if you use all these test methods together, you can end up with something like this. A very nicely painted birdhouse. Everyone's happy, and there's no spots for bugs to get in because you've painted everything all together. So this Nrwl Storybook plugin is relatively new. It's just released in NX 8.8, I think, and so there's going to be issues. If you have ideas, if you find bugs, file an issue. If you have ideas to make this better, contact me. I'd love to hear from you. So thank you for listening to my talk. Thank you for your time, and happy testing.